Welcome to qnawire.
Hello and welcome to this video solution of numeric. So here we are given that at a construction site there is a 65 kg bucket of concrete hangs from a light but strong cable that passes over a light friction free pulley and is connected to a 80 kg box on the horizontal roof, right? So this is, let's say, M1 I take, right? M1 is 65 kgs and there is a pulley with which a box of 80 kg is connected. So this is M2, that is 80 kgs, right? The cable pulls horizontally on the box and a 50 kg bag of gravel rests on the top of the box. This is M3, let's say 2 kgs, right? The coefficient of friction between the box and the roof are shown. The static coefficient is zero point 0.7 and kinetic coefficient of friction is zero point 0.4, right? Now you have to find the friction force on the bag of gravel and on the box, right? So here, now this is pretty simple. So the frictional force Fr, let's say, will be equal to mu times the normal reaction, right? And this is mu s because it is stationary. Mu s times the normal reaction will be m2 plus m3 times g, the total weight, right? And here you can apply, this is 0 0.7 times of M2 is 80 plus 50 times G is 9.8 Newton, right? So this is around 891.8 Newton is the frictional force is what you have. Now B, suddenly a worker picks up the bag of gravel and here you have to use a conservation of energy to find the speed of the bucket after it has descended 2 meters from rest, right? Now what you can do is you need to once you pick up this gravel, then you have to compute the acceleration of the system, right? So here m1g is acting down. This is resisted by the tension T. Here you have the tension T acting, and this is resisted by the frictional force Fr, right? And now let's calculate Fr after the box of gravel has been pulled, right? Which is mu times of now this is mu k because it will be moving with some velocity, right? Mu k times only m2 will be there, m2g, right? The gravel has been pulled off. So this is zero point 0.4 times of M2 is 80. G is 9.8, right? And this is 313.6 Newton, right? So here, if we just write down both this equation, let's say the system will move with acceleration A, M2A, right? So here you will be having M2A that is equal to T minus the frictional force, or here the tension T will be equal to M2A plus the frictional force. This is equation 1, and on the other block you have got M1A that is equal to M1G minus the tension T, right? And in the place of tension you can have M1G minus this is M2A minus the frictional force Fr, right? Or A will be equal to A times M1 M plus M2, that's equal to M1G minus the frictional force A times the sum of the masses are 65 plus 80, that is equal to M1 is 65 times G is 9.8 minus the frictional force is 313.6. So the acceleration will be equal to 2.23 meters per second square. Now you have to calculate the velocity, right? After it has descended 3 meters from rest. you can apply v square equal to u square plus 2as, right? So v square equal to u is 0 times 2 is 2.23 times the distance is 2 meters. So the final velocity v will be equal to 2.9, or you can approximate to 3 meters per second is the final speed, right? I hope this is clear to you and a very good rest of the day. Thank you.